Hi, Miss Marion here. Let's go ahead and turn to page 121. Let's go back there and let's go ahead and write a sentence about, I know how to decide if two triangles are similar just by looking at their angle measures. This is our goal for today. Give yourself a number one. I don't know. 2, I kind of get it. 3, I got it. But then 4, I can teach it to my friend. Go ahead and write your sentence and your number at this time. Now, since you've written your sentence, let's go ahead and turn to page 67. And this is our starter for today. Create 3 different expressions that are each equal to equal to 20. Each expression should include only these 3 numbers only. So go ahead and pause right now. Go ahead and write down 3 expressions that equal up to 20. So here are my examples as far as different things, as far as expressions themselves. So I can do 4 times 10 and then give it a negative. So negative 40 divided by a negative 2 makes 20, okay? 10 divided by negative 2 is negative 5. Give it opposite, which is positive 5, times 4 equals 20. Remember, you have to do order of operations first, right? And then I have 4 divided by 2 is negative 2. Do the opposite, which is positive 2, times 10 equals 20. You might have had something different than this, so it's totally fine if yours is different, but make sure that you have 3 expressions written on page 67 underneath the 6-1. If you look at 8.2, it says making pasta angles and triangles. So we would have done this as an activity in class. And unfortunately, we are not doing it because we're not in class, and I'm sure Mother does not want you playing with her pasta and making triangles. So we're actually going to, unfortunately, skip this activity at this time. This is kind of what it looks like on page 67 and then also 68. Your teacher will give you some dried pasta and a set of angles. Create a triangle using the pieces of pasta and angle A. All right. Unfortunately, again, we're not doing this activity because I don't think your mother really wants you playing with pasta at this time. So if we would have been in class, we would have done it. It's actually a lot of fun. But we'll actually kind of point out what we are supposed to learn from this in a second. So on page 69, you can actually see this triangle and number 3. It says, here's triangle PQR. Break a new piece of pasta different in length than segment PQ. We're actually not going to talk about this with the pasta stuff. Again, if we were in class, we would actually be doing it. What I'm actually do is I'm going to draw on this triangle, and I'm going to make a line segment on P to Q, but I'm going to make it shorter. So I'm going to draw on it, and I'm going to go, okay, I'm going to go a little bit shorter than P to Q, and I'm going to label this N. And then I'm going to draw on P to R, and again, I'm going to make it shorter, and I'm going to draw on this and then make this S. And then I'm going to connect S and N together. So as you can kind of see, I have 2 triangles. Right now, I have the bigger triangle, so I have triangle PRQ, and then I have triangle PSN, and I guess the question is, are they equal? Are they exactly the same? Are they congruent? No, they're not, but are they similar? The answer is, as far as if they're similar, that answer is yes. And how can we actually show that? If we look at the different things, this angle is the same. And then if I took this triangle and kind of shifted it over, would angle S and P be the same as RQP? That answer is yes. These angles are going to be the same because we also made it kind of on that triangle, but we made it shorter. Pretty much what we did is we dilated it, and the center point of dilation was P. We made that shorter, and we can actually show that these triangles are the same, just kind of looking at the angles themselves. Are those angles the same? Well, yes, they are. So we have to remember that when we have similar triangles or we have similar figures, if the angles are the same, yes, they are similar. And then the side lengths, they're actually different. They're different lengths. And that would also make it similar. All right, let's go ahead and turn our page to page 70, and we actually see this picture. And it says this diagram has several triangles that are similar to triangle DJI. Let's go ahead and look at that. So this is the triangle we're looking at. And it says 3 different scale factors were used to make triangles similar to DJI in the diagram. Find at least one triangle of each size that is similar to DJI. So what I did personally is I took my trace paper and I traced that triangle, and notice how I kind of labeled different angles. These two look the same, so I kind of labeled them with 1. And then this one is different, so I kind of labeled with 2 kind of bump kind of things. And I traced this triangle. And I'm going to use that to go ahead and find different triangles that will be similar to this triangle here. So what I'm going to do is I'm going to check and see if triangle DJI is similar to this bigger triangle here. So triangle DAB. So I'm asking, is triangle DJI, is that similar? So similar is this little symbol. Is that going to be similar to triangle DAB? So as you can see, what I did is I took my trace paper and I checked to make sure that this bottom angle is the same as this one here. So as you can see, I took my trace paper and I made it so that that angle that I traced, which came from here, are those two the same? Well, yeah, they are. And then what I'm going to do next is I'm going to check the other angle. So I'm going to check this angle over here to see if it's going to be similar. And again, I'm going to be using my trace paper. And as you can see, I went ahead and I moved my trace paper over and I looked at this angle here. So this trace paper is this triangle up here, the original triangle. And is it similar? Are these angles down here similar? Yeah, so I have these two. Actually, I have all 3 angles. They are the same as the original triangle DJI. And so is this bigger green triangle similar to the red triangle? Well, that answer is yes, because those angles are exactly the same. The side lengths are different, but the angles are exactly the same. So the answer to the question that we asked before, are they similar? Well, yes. Right? And a happy face. Okay? So that is one of the triangles that's going to go ahead and be similar. We are looking for some other ones also. Now I need to go ahead and find a second triangle. So I'm going to go ahead and I'm going to look at this one right here. So is triangle DJI, is that similar to triangle ICB? So again, what we need to do is we need to check those angles and make sure that they're exactly the same. So again, I'm going to take my trace paper and I'm going to check that. So here is my trace paper and I'm checking this bottom angle here. So notice how I took it. This is my original triangle, DJI, and I'm checking the bottom angle. Are those the same? Yeah, they are exactly the same. Now I'm checking this top angle here. Is that the same? Well, here I took the triangle, I moved it up. Are these ones the same as the bottom? Because we know the triangle's upside down, right? So are these exactly the same? Yes, they are. And now I'm checking the last angle, so this angle here. Again, I'm using my trace paper and see are those equal? Yes, they are exactly the same. So we've shown that all of these angles in this blue upside down triangle, are they congruent or equal to the original triangle that we're looking for, the triangle DJI? Yes, they are. So is this blue triangle, is that blue triangle similar to the original triangle? Yes, it is. Now we need to go ahead and we need to find one more triangle that is similar to that original red triangle, the DJI. And what I'm going to do is I'm going to look at this one over here. Is triangle, so again, we're going to ask the question, is triangle DJI, is that similar to triangle EJF? And we're asking that question. So again, I'm going to use my trace paper and figure out if they are the same, or if the angles are the same as what we're checking. So again, I took my trace paper, and this is the triangle that I had. So see how it's kind of overlapping each other. Is this triangle equal, so the triangle DJI, is that equal to the triangle it's sitting on top of, which is EJF? Are those angles the same? Yes, the angles are the same, so it is similar. Technically, it's congruent, but it is similar because the angles are exactly the same. That's actually what we're checking for today. So here, as you can see, these are the 3 triangles that are similar to the original triangle DJI. And the reason why we know that is because we showed on each of those angles are exactly the same as the original angle. Just the side lengths are different. That's why it makes it similar. So as you can see today, is what we're doing is we're looking at the angles. So if I have triangles that have the angles are the same, so there's 50 here, 50 there, 60 here, 60 there, and then that kind of forces this angle to be exactly the same because of the 180 minus 50 minus 60 will make that third triangle, and they're going to be exactly the same. In fact, let's go ahead and find that. So let's go ahead and do 180 minus 50 minus 60, and that answer is going to be 70. So that makes this angle here 70 degrees. Well, you could do exactly the same thing over here, 180 minus 50 minus 60, and that equals 70. So that angle here is 70. So are all the angles, these angles, exactly the same as this triangle up here? Yes, because the angles are the same. These 2 triangles are similar to each other. Notice how we have a smaller one, and now we have a bigger one. They are similar. So one bigger, one smaller, and there was a scale factor to make that happen. But again, today what we're looking at is we're checking the angles. If the angles are congruent on a triangle or any type of polygon, then those polygon, triangles, figures, whatever you're looking at, they'll actually make them similar. So let's go ahead, let's turn back to page 121, and let's go ahead and write a sentence about today's lesson, or what we're doing is I know how to decide if 2 triangles are similar just by looking at their angles. Go ahead and write yourself a sentence, and then give yourself a number, numbers 1 through 4. 1, oh, I don't really get it. 2, I kind of get it. 3, I got it, but then 4, I can actually teach it to my friend. So this is our lesson for today. Make sure you have that sentence. Make sure you have that number. And then, so this is our lesson for today. We're looking at the angles of a figure. If they are exactly the same, then the figures are similar. And then make sure you go ahead and do the practice problems. And you can find those in Canvas underneath modules. Have a good day. Thanks.